Okay, so this is our Coverity and crash testing stuff. I'll do the crash testing first because it's relatively straightforward. We've just got like one big um, piece of hardware sponsored by Finance. We have this test harness at this link here. And we have a whole pile of test documents. We have this 800,000 plus test documents, which we've gotten from a bunch of sources. A lot of them are from Bugzilla's. There's a script that we have that pulls them down from all of those bug trackers, the attachments on those bug trackers, and then this additional script that Cisco put together to scrape documents from various forums that have relevant documents to our own stuff. So that's just a few of the places that they come from: the Open Office forums, LibreOffice ones, Microsoft Office ones, etc. So there's a huge amount of documents there, but the vast majority of them are Excel documents. Like we've got 600,000 plus Excel documents, and the rest of them make up that remaining gap. So we're very heavily biased towards calc in the crash testing. That whole process takes about 3 days from start to finish. And what it does is the build itself is built with debug utils enabled, but optimized builds. So we have the certs and the extra debugging level, debug util level asserts are enabled. So we're getting more than just like crashes that the user would see. We're getting asserts that would go unnoticed there. So statistics are kind of biased towards being more strict than you'd get in maybe a real life scenario. So we load that, whatever, 800K documents, save them out to a whole bunch of formats, and then we reload our output again. So the crashes that we're looking for are in all of those various steps. And it takes about 3 days. And then the output is raw at this URL here, this one, the build devs URL, the crash tests, raw results of what crashed is there. And the back traces are collected and dumped up there as well. I take that raw text and I turned it into something a bit more structured at the above link, merge together the crashes that have the same backtrace and so on, and categorize them into what's new, what's recent, and what's kind of historic, what we've had for a long time. And there's a few cases where a crash will appear in one result and disappear in the next one. So we have a small number of intermittent failures, which may actually be fixed now. We have to give a couple of runs in a row before I'm convinced of that. There's only 5 actual distinct crashes at the moment, or asserts, 16 documents in total. So out of our 800,000 plus documents, we've got 16 cases that are causing us trouble. So that's basically what the crash testing is, how it works. You can use the crash testing as well if you're a developer and you're looking for a particular type of document. You can add in an assert on the condition that you're looking for, and the crash testing will find you that case as well. So sometimes we use it for kind of searching or corpus of documents for particular cases. That's crash testing, straightforward enough. The other one then that's listed is the Coverity. Coverity static analysis. We've been doing it for a long time. In this case, you build locally with the Coverity tooling. You upload the results up to their server, and then they do the static analysis up there. This is with the free version that's available for free software like LibreOffice. That scan.coverity.com case. There's a couple of limits. It says for something over 1 million lines of code that you get maximum 1 build a day, a maximum 7 builds a week. So we do tend to be less than that. I think recently we're kind of pushing them out of maybe one every day and a half as I try to work through a certain amount of backlog. With this free version, there's a new version, I think, about every 6 months. And when a version was released, then the second earlier version is end of life. So you're forced to upgrade at a certain point, which is relevant for the varying numbers in the charts that are coming up. I try and do this build and the same setup for as long as possible before I'm kind of forced to upgrade that. So I build it on a little Docker image, only build it against LibreOffice's own code. Third-party libraries are excluded from the run, but many of those third-party libraries have their own separate independent Coverity analysis done on them, that list there. So this is the dashboard that gives the kind of overview the current situation kind of up to date. They have this defect density concept where it's the number of defects in 1,000 lines of code, and ours is 0.07, 6 fixed in the last run, and historic numbers for how much lines of code from their perspective their analysis runs on. And so this is their defect density over time, where they claim that the average defect density of open source is at that particular number, and then the blue line is R1 over time. And what happens, of course, is that there is a release of Coverity. So this was our release of Coverity that I went up to, a shockingly high number. So I rolled back to the previous version. And then at this point, we're basically forced to upgrade because the version we're using here has end of lifed. And now we're back up at making some progress over time to deal with the new categories of issues that the latest version has come up with. I'm not entirely sure, but I think it's the case that this line here is updated when they do a new version of Coverity. I remember this average line for open source being about 0.5. So I think this line versus this graph is correct from their perspective with the most recent version. This is a kind of a very old page because it's difficult to get a full list of all the kind of things that Coverity checks. Coverity is like a huge bundle of checks. This is an old list, but it gives you a kind of overview of the kind of different type of things it checks. It checks the various classic cases of you have new and delete of array type versus normal type, or you're allocating with new and deleting with free. Then there's a whole bunch of issues like pass by value when you could be passing by reference. And then most of them are the case of you are dereferencing something, and then later on you go on and you null check it. So if you're null checking it after you dereferenced it, it doesn't seem to make a whole lot of sense. So it's a lot of kind of consistency checking. And for the most part, Coverity is more kind of a weird code detector than it is an actual flaw detector. So in a lot of cases, it's indicating that your code is quite non-standard and is either unable to figure out what exactly you're trying to achieve. Wrapper escape is when you have like a standard unique pointer, you get the result from it, and then you delete it, for example, that something has escaped from a managed pointer and you're using it in an unusual direct raw pointer kind of a way. There's a few examples later on. Again, sorry? Somebody had something to say? Nope. All right. Again, it's the free service, so you get the default set of checkers. If you get the commercial one, the analysis will run on your side, not on the server side. Like you have your own server or your own instance of it, and you can customize what checkers you want, whether you want this entire batch or you believe some of them are more trouble than they're worth in your case. But as far as I can tell, at least in the free service, you're just given a default set and you live with that, and you don't get to pick and choose which ones you want. It checks 2 languages. It checks multiple languages, but for LibreOffice, it checks 2 languages. It can detect Java issues as well as C++ issues. As far as I can tell, the Java stuff is spot bugs, kind of a separate project, and it gives spot bugs reports as well as C++ ones. I find the spot bugs ones maybe not that useful. There's been a few things that have been kind of useful from it, but for the most part, it's the C++ one that seems to be the most effective. And a lot of the interesting ones in the C++ one are based on some percentage of checks. So if you never null check a particular result from a function, it's silent. If you null check it 99% of the time, it'll certainly complain if you don't null check it that other time. But I'm not entirely sure where the cutoff is between these 2 boundaries, whether it's 60% or 70%. And so you get cases that something is silent for 10 years on some aspect of the code, and then there maybe 2 additional checks are done elsewhere, and then this old code it suddenly is revealed as, well, you've checked it 98% of the time everywhere else, and in these ancient cases, you never bothered. So you can get these cases where old code suddenly starts getting warnings where it didn't have warnings before, which can throw you. After that, it's just most examples of what it can do. That's what I was saying earlier about null dereferencing null return value. So you'll find that this one here looks perfectly fine, but if you check in the various details, you'll see that it has been checked 16 out of 19 times everywhere else. So relatively recently, we have started checking return code from this acquire theme, because we see in the Document Foundation statistics from the crash reporting there that it can return null and has been crashing. So added additional checks, and once we hit some threshold, then code that we hadn't touched starts getting reported as being the outlier in terms of getting checked there. We do have an internal ability to annotate point functions where the return value should be checked, but it's only enabled on the Microsoft builds. So it could be the case, for example, that while we have turned this on for that, this could be Linux only code, which we wouldn't have found otherwise. And the same then, just kind of logical checks here. Like here, we've obviously checked p-text for null, and then down here we have unilaterally dereferenced it anyway. So this is going to crash. Either this is going to crash and that shouldn't be allowed, or also it's equally possible that this check here is redundant and should never have been checked. So it's never entirely clear until you look at it closer, which is your best option. Other things you can do, self-assignment. This doesn't make a whole lot of sense. Relatively recent as well. A little rework of this had ended up with this case here. So another example of the kind of thing that it finds. Uninitialized members is another common one that comes up. You can tell if you have a struct and nothing is initialized, that's not a warning. But if you have something where everything is initialized except for one value, then that will get warned about. And again, there is some kind of a threshold here that's not entirely clear to me. At what percentage does it flip over into? Yeah, you have uninitialized values here, but you've initialized nearly everything else, whether it's 10% or whatnot. What happens commonly is that somebody adds a new member, but there's two constructors. They remember to add it in one constructor, to initialize it in one, and not initialize it in the other. So that arises relatively commonly. Now that was kind of the classic ones, and then there's this peak in the chart that was done earlier. Where's that peak coming from? What the most recent version of Coverity has learned, maybe 3 versions, has been to detect cases where we could use standard move rather than just doing a basic copy. So it's looking at things that go out of scope and are not used from their last being assigned from until it goes out of scope. And if that thing has a move, assignment move, or a move constructor, then it says you're missing an opportunity here for an optimization on the assumption that the move is more quicker than a copy. Otherwise, why would it have it in the first place? So there's a lot of them in LibreOffice. I think most of them, maybe basically all of those, are now solved. So that big, huge block is cleared. And the other one then is this improved return value. This is very old code. It started getting detected recently. Our value here is a 64-bit value, and it's been checked here against like maximum 64. Now for a start, obviously it's not going to be larger than maximum 64, but it seems that the intention here is to chop it down to the largest signed int value it can, so that it can pass it into something that only takes that and this loops and chop it up into sections. But clearly it has the comparison here is wrong. It should be trying to compare against this value and not that value. So this is a new overflow return value issue. That's the good case. It has lots of overflow return values that are harder to read and parse than this one, but that is part of the new set of things. Strong direction. Overflow constant is new as well. It can detect and read from the code in get token counter that could indeed be a 0 that's returned from that. So 0 minus 1 assigned to in count overflows, and then this is all very dubious after that. So this case is detected. Another one here has been detected recently, which is also reasonably useful. We've assigned 32-bit value here, and this is our condition of an unsigned 32-bit. and there's like whatever 15 or 16 examples like this, and the other 14 of them are using maxint, and that was the one outlier there. The other thing then we have a lot of that has been detected recently is inconsistencies in the locking. A lot of these, this one's pretty good in the sense that if you look back over the history of this one, of the code here, is that while our lock is here, this ex-listener is passed in, so that's neither here nor there. What's relevant is the MN client ID, is that we're using this MN client ID while it's locked, but we're also using it before it's locked. And the query is from Coverity, is that really something that you want to be doing? So you've assigned it here with a lock held, then you've checked it here without a lock held. And if you go look at the history of this, at some point this was inside the lock and was moved up and out of it, kind of as a side effect of some other idea that had no intention of removing it from the lock. But on the rest of the cases, there's a couple of hundred of them, well, maybe 100 of them, where it's not quite so clearly that there is reading and writing of things, one with locks held and one without the other. And then whether to fix that would cause a huge degree of deadlock possibilities is a concern. So they're mostly being left alone for now. As against that, this other new double lock check, and expand this in a minute, is much better, has picked up a whole bunch of regressions, and I think we fixed all of them except for one. So we have a lock held here, and then we do something, and it's clearly not obvious what this goes on, but we can expand with the show details a little bit more, a little bit more, and a little bit more. So it has done a fairly deep analysis to see that you have this lock held here, and we've called a string of things. And at the very bottom of this, you're trying to acquire the same lock, and these are not recursive locks, so that's going to deadlock or throw, give you some unexpected problem there. So it does a pretty deep enough dig down through what calls what. I don't think that would be easily detectable by any other means, really. That's all the good stuff. False positives are the bane of all these things, and just what you can do about them when they show up. The simplest thing is that you can select them in the UI. You can just dismiss them and forget about them. Done that for these dubious spot bugs issues. The other possibility is that you see some of this markup inside the code of like this Coverity copy paste, blah 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 blah, and that'll automatically dismiss it. Plus of that is that when the code changes or you move something around and all the rest of it, the annotation moves with it, and the new location doesn't get reported about, where it's just dismissing them. It's pretty good at detecting that it's the same code, but eventually it get refactored sufficiently that it's seen as new code and the warning returns. So the downside of manually dismissing is that it returns. Downside of it in those annotations is that you've got this extra glue around the place. But for the most part, because the build is done with asserts enabled, throwing asserts at most of these warnings solves your false positives and helps the humans reading it, that they don't have to worry about these conditions either, because they're not supposed to arise. And these last two versions that have brought in these mutex checking and all the rest of them have a bunch of annoying warnings as well. They start reporting uninitialized members in, I think, nearly every lambda that's used is claimed to have an uninitialized variable of some kind or other, and the same for standard mutex. So you tend to get one good warning about a double lock and maybe three warnings around it that are spurious about uninitialized mutex values. So anything that's spurious has just been dismissed, especially as this one is mentioned in their own release notes for the up and coming versions as being fixed. And what Coverity has tainted data, like a lot of these checkers, where it detects that certain arguments have come in from the outside world. Either it does that by seeing there's some byte swapping going on, so it can assume that the data is coming from disk or network or whatnot, and this data then is tainted, and if it's tainted, then it assumes it could be any value. So it could be, if it's not bounds checked in some way, you get all these tainted, untrusted data warnings, which we've had in the past, and I fixed a load of them, very helpful for the binary file formats or anything that comes in from an untrusted source, and that's all to the positive. This latest version has seemed to have started extending this concept to other values. So there's a load of places where we might return -1 as an error code, and we're checking for -1 as an error code, but the data has been tagged as tainted, at which point it assumes that it can be all sorts of values, and that you have to bounce check it on both ends for Coverity to be happy, which is not really a positive direction that's going there. And even with some of those checks, and this is the final one, you get these kind of false positives, which are a complete head scratcher. And this is additional debugging code here, which does not actually exist in the real version, just added just to see what does Coverity think about it. But the actual code index of sub node can return -1, which is fine. But despite an assert that it's going to be between this bound and value based on some nodes, it's still not happy with that. It's also not happy with this check either. So it's still claiming that there can be all sorts of difficulties down here. The data has been tainted. This is not considered sufficient to untaint the data. Either it doesn't see it properly or can't expand that out to some discrete exact value to know if it's safe or not. So it's uncertain what sort of analysis Coverity has done here and what would be needed to do to keep it happy. So yeah, that's Coverity, the pluses, the strengths and the minuses, and the way things are at the moment. And that's kind of all I got. If anybody has any comments or anything you're interested in.
Thanks, Caolan. Looks really good. So getting back to the last page, isn't it the +1 that's the problem, the overflow?
Yeah, it claims it has to be +1, but +1 of what? What difference does it make,
So I guess if you have a very large number, it could overflow when you.
That's it. That's it. But it's because it has claimed it's tainted. It has claimed that it can be that kind of a value. It can claim that, but it doesn't do that for any, generic piece of code or returns back a number. It has suddenly decided to trigger it on this index subnode, and the only thing that's unusual about that is the ability to return, a value less than 0. But if you follow it by its claims, if you follow by the claims here, it may be less than 0. Well, if it is less than 0, then this doesn't arise. So following it from its list of claims gives you inconsistency here. So I think what it basically is saying is a possible return value of anything whatsoever about what this kind of style thing normally works, but doesn't work in this case. I rather suspect that putting in an actual number here will clear it. So I'll experiment with that. But even if it does, is that really something that we want to start sprinkling? Well, I don't know. No. We can. No. And what I have been doing so far is a couple of if defines based on Coverity. I might start doing the same kind of thing that Stefan does for weird GCC bugs and put them behind a Coverity version check. And every time a new version comes out, then the old ones that are no longer necessary can be dropped, so we don't end up with endless amounts of workarounds.
Yes, I wonder. Sorry, go on.
Sorry, Ash. I wonder if you put in the get num subnodes method an assertion that it is less than max in less than 1, or whatever. That would.
It might work. Yeah, it is that kind of level of guesstimates that I try on. The code, the one I upload isn't exactly, vanilla code. I've added in, I've got 16 experimental patches on new warnings, of which 14 of them work, and so on. So yeah, it's trial and error to find out what way it is actually parsing.
Yeah, sorry, Ash. I talked to you. What's the?
No. This is interesting. I'm wondering if this is an undefined behavior check, meaning if we replace the signed integer with unsigned, is it still going to trip up the same check, or not?
Yeah.
Or
it will. It won't take the letter of the law, and once you give it to something assigned, say that's great. It'll keep tracking it as a negative number was put into an unsigned, and then that is used later on. So that doesn't help.
That's interesting. Because it is tripping on the +1. That's why I'm asking this, right? Okay, that's curious.
Yeah.
Is
So
this something we can report for Coverity to improve? I mean, it sounds like this is something they can do better at, I feel.
Yeah, there is there is a user support forum that you can register and log into and all the rest. I haven't logged a bug in it. I know Stefan has in the past. I don't know, did he get any kind of outcome there? But I haven't logged anything there myself because that's a multi-step process that I haven't heard about any outcome in the past being worked.
Another random question. Going to jump in. SonarCube sell like a developer option for like $160 annually. That seems to have more features than the open source community version. And I wonder, should we just buy that? I mean, it seems inexpensive and useful.
Yeah, you'd certainly get a support contract with that as well, where you could file your bugs. But I think the only thing, I don't know whether it matters or not, is that it'll probably not be the same instance, so you wouldn't get your historical numbers back for X years to see your trends. Whether that matters or not, I don't know, but it would just be the only thing that comes to mind. I don't think you'd get like a supported version on their web server. You'd have your own one.
Yeah. Yeah, interesting. I mean, just quite interesting to look at the pricing page there and see what we could do. I suspect we should do that at Collabora at least. But let's talk later. Well.
All right. Anything else?
How useful are the other sort of various linting and we've got lots and lots of different static checkers going on now. How useful is Coverity versus those? You know, or is it becoming decreasingly useful as our checkers get better, or is it still catching?
There was a period where we couldn't use it at all because our version of GCC had gotten ahead of Coverity's version, and we have a bunch of checkers. So I could certainly see that if we could increase a few more of our checkers, I mean, like the uninitialized members of a class, I think you could probably knock that together if you know our whatever they're called, client plugin stuff. Let's say that's probably trivial to do, and that's like a lot of the issues. So I think we could probably replace some of them are straightforward enough if we had to. These new ones about the double lock, for example, yeah, they're pretty good. I don't think that'd be so trivial for us to do. Maybe I overestimate how hard that is, but it looked tricky to me. Yeah, and I suppose the other thing is they do add new things every now and then, and the new things do find things. So I don't know too much about the other checkers. I mean, there's a PVC one. I think that's how it's called. That seemed pretty good. They gave us a kind of a one-time analysis of what was wrong, and there was certainly things worth finding in that.
I just wonder, the more we can use compiler plugins for the most frequent Coverity problems, the less you have to do, and the more other people do as they check stuff in, right?
Yeah, I mean, the earlier the better. With the detected is obviously better.
Yeah.
So it's kind of our own compiler plugins. I think are pretty plus useful. I mean, with other projects, people who have less amounts of code, or if we had the commercial license, I suppose that's another thing. You can run Coverity integrated with. I know with GitHub at least, there is an integration mechanism for Coverity and your particular commit that you've just written. So I don't know if that's feasible in Jenkins land or it's even possible with the larger body of code there. But that is.
Yeah, I saw the CI integration there, which seemed quite exciting. Although with the size of product, I wonder how quick that would be.
I think with the size of the product, at least with the free version they have, I think their idea is that you put a branch or something, or you set it up either way, and it's kind of like a once a week automatic kind of a thing. So cut down on any manual work.
Yeah,
it wouldn't give you that immediate feedback that you have just attempted to, add something complete.
Yeah. Nice. Presumably
I was
before-
wondering if, sorry, I was wondering if we were looking into logging crashes in runtime as well of our customers. We have now services like Sentry or things like this where we can embed something, and essentially it gets us a stack frame like the first tool would give us if it finds a wrong document. I was wondering if we had looked into it or if it had been evaluated in the past already, something like this.
Well, if that's to me, I know that for the upstream LibreOffice one, there is the crash testing there, and Cisco has the spreadsheet that comes out once a month as to what the crashes are. And I don't think we have something as straight as automatic on our own side, on Clever side. There is some work there at least, and there are numbers and there are output. It's always hard, especially with the results I've seen from the, should we say, the TDF one. A lot of the problems are on Windows, and you don't seem to get the same kind of quality on the optimized Windows backtraces than you get on the Linux ones, which are, of course, getting more and more difficult, I think, as time goes on with lambdas to parse. So I've had only limited success in fixing, just from the backtrace that I look at when Cisco puts it out. We could get one or two anymore.
Yeah, but our own builds would have better traces and they run on Linux, so we'd have a better chance. And also, it would pass also the WST part if it was on our customer supported users, for instance, machines.
Yeah, especially when you can be sure you have the right matching debug info.
Well, we make the build, right? So we can make sure that it is there in the Docker image. Or
I don't disagree. I don't disagree. I just don't know off the top of my head too much about.
Yeah. All right. So the general answer is maybe there's something regarding this kind of stuff, monitoring crash services. The conclusion, if I gather well, is we haven't evaluated much. There might be some opportunity.
Yeah, could be.
But that's really.
I would have a question regarding the crash testing side. Did you ever have a successful local setup of that? It's a very useful service, but when I last looked at the code, it was close to something that runs on one single machine, and it's very hard to set up locally. And I was always unsure if that's me or if the code is really that bad, even if the service itself is excellent.
I haven't done it too recently, but I have set it up locally. But I have used, I think, I have used the exact same paths that locally as exist on the server. So I haven't, customized it or things. Now that said, that was before Gabber for Allotropia went in and added some various configuration values and did some tidy up work a while back. So I think it's probably easier now, and from work there done, I imagine a lot of that work was done to make it easier to run your own one or to run it locally. So yeah, but I do tend to run shorter experimental ones just with the email and reporting turned off, and I run that on the server itself because it's less effort for me than to set it up locally. But I have done it in the past.
Yeah, I see. Thanks. So the container setup without containers, type of thing.
Well, I don't use the containers for the crash testing, just for the
Sure.
Coverity.
Yeah. Okay, thanks.
Go ahead, Cisco.
So, do you know if it's possible or if you have tried to run the crash testing on Windows?
No, I haven't. No. and the Coverity could be run under Windows as well, but we don't. So there's quite possibly some Windows only issues that are detectable that we've never detected.
We do, however, run a similar thing to crash testing, but testing Microsoft Office interop on Windows. So there is a tool which we should run more and analyze the output of more, which Erin is looking at the moment, written by Pranam and also Neil, that essentially uses a Collabora line converter and then sees whether the output is still loadable in Microsoft Office. So it's looking for export problems that we don't detect on import, but Microsoft complains about, which is quite nasty. I think we're quite good at interoperating with ourselves in Microsoft formats, but perhaps less good at finding regressions and generating bad Microsoft XML files.
That does sound very useful indeed.
Yeah. I mean, it would be more useful if we processed the output and looked at what was going on. So it's quite a chunky. Yeah, but that's built on the crash testing corpus. So we essentially use all the crash testing files, and then we have stats on how many of them Microsoft can load and we can load and this sort of thing. Yeah. If you want to play with that, Cisco, that'll be great.
Okay, thanks for your answer.
And that code is on GitHub someplace.
Yeah, it is. Yeah, it's in where is it? Collabora GitHub. So I'll paste a link to it. Second. Yeah, it's called MSO test. And of course, it has to run on Windows in C#, etc. Blah blah blah, and that's the link.
Okay, anything else?
Any question? Can we add the document? How do we add the documents? Can we do that for customer documents when they are accord agreement at least?
Well, what the model I kind of had.
Let's say we get an issue with some document, and we'd like to add it then to prevent regressions on them.
Well, for for not having regressions, these in-source tests, which are probably far better because they can actually check that the exact thing is fixed, whereas the crash testing is check the crash testing itself. That said, the way I was running it was that when we got down to 0 crashes, then I would update the pilot documents from the usual bug trackers and forum sources. We haven't been down to 0 in quite a while, so it's probably about nearly a year out of date at this point. And on top of that, then, apart from all those directories I mentioned, I have another directory which is just my own name, which is piles of documents that have accumulated myself over the years that I don't know where they come from, various CVE reports and things like that. So there is a kind of a miscellaneous directory, but generally I'm not putting anything in there that's from any customer or anything like that.
So customer documents are inviolable and they shouldn't be they shouldn't be used. We should create new exemplary documents that can be used ideally in unit tests, as Caolan says. So, yeah.
And in many cases, it actually helps to have that process that once you can create a from scratch document that reproduces the problem, then you almost understand the problem, which means you are almost able to fix the problem. So there is some great value in creating a public reproducer.
And I just think keeping customer documents around or secret documents around in large corpuses is a problem. We used to do it in GNOME with numeric, and there was like a monster secret repository of random people's confidential documents containing God knows what personal data and and it's like, really, you don't want to be going there in today's world, I think.
One of the other things that's mildly interesting about the documents we have is that some of the bug trackers have gone that we got these documents from. So I think that we now back up these documents to give to a backup of them, but in some cases they might be the only copy of some of these documents that are left or inside this bug tracking. So the IB source bug tracker has gone down for a couple of years ago. The Novell one went private some years ago, and so on. So these things are beginning to disappear. Older documents, places where you get older documents, are beginning to disappear.
Do we suck things out of search engines, Caolan? You know, so when Google says there's 7 million hits for XLSX or whatever, do we?
No, we don't. I think I looked into it at one stage, and I don't know, I got distracted, or it wasn't trivial, or it was no fun. I did it. But, you know, when the 600,000 Excel documents dropped out of nowhere on a Tuesday, that was a bit of a land. So it can take time to integrate these findings.
Yeah.
Yeah, Michael, that's something I also tried, but I didn't have any success with that.
Yeah, it's a shame, isn't it? We should.
I think there's a degree of kind of Google closing down some of these things as well, because they're being used by people to search for private data or for accidental documents being left in the web or things like that. It's not as easy anymore to get Google to give you the results that it used to be able to give. What I did do, but it wasn't for crash testing, was to go to European Union pages. They have vast quantities of very large documents, often in Microsoft Office format, on the various European Commission pages, treaties and protocols at 300, 400 pages each. So there's plenty of sources of big, long, complicated documents. But that was for finding big documents to work with, and not for crash testing purposes. But that is a potential source of good stuff.
Maybe we should sort of, when a company goes bankrupt, buy up its documents or something, sort of historic. Yeah, I mean, it does seem odd that there are trillions of documents in the world, and we have.
Yeah. You think it would be fairly straightforward of, Google, give me 700,000 documents, and it's not as easy as that. Maybe some of the other search engines have ways of doing it, but it's not obviously straightforward.
Yeah.
So, any more questions, anyone?
Yes. Are we strictly constrained to GCC, or could we use letters from CLang as well? Because there are some that are pretty easy to run.
I think all the ones we have are Clang plugins. I think.
All right.
I'm not sure, but that's my thinking.
Probably.
Noel and Stefan are the ones who write them and know about them. I just know about them.
If you've hacked on GCC, you'll realize why Clang plugins are a good thing.
Fair enough.
All right. Anything else?
Normally we poll everyone. I don't know who hasn't spoken or said they don't have a question. Say, if you don't have a question, say it affirmatively in the chat. How about that? Otherwise we'll persecute people. Darshan, do you have any thoughts, questions, comments?
No questions. Thank you.
Michael.
Thank you.
Nope. Rash, beat me to it. Attila? Byram?
I don't really have a question, but I can share my opinion about Coverity, because one of my previous company, we used Coverity and they bought its license because we had a lot of projects, but we still used it rarely. I mean, they had a system similar to our CI, and once a week or something like that, it was run, and we just checked it sometimes, and it was enough for us. So I think for us, we don't need licensing it, but it's just my opinion. And I remember it was running very, very long time. I mean, some project needed like 1 day to finish the Coverity.
It's about a week for us, isn't it, Quill? How long does it take to do the Coverity run?
Coverity itself has become much faster to run, and I think it might be from end of upload to return time is in hours now, so 8 hours overnight is the kind of thing I want to say.
Wow.
Yeah, about 8 hours.
But it used to take a lot longer, right?
It used to take 2 days, to take forever. You forget that you spawned that, and suddenly the email would arrive that there was issues. So yeah, I think it's nearly possible for us to do back-to-back builds and get maybe 5 or 6 of them done in a week.
Cool. Well, I think that's it then. I think everybody has had a chance, if there's nothing else. Thanks so much, everyone. Thanks, Caolan. Great talk.
Thank you. Great talk. Thank you.
Thank you. Bye-bye.
Thank you.